Hello out there. Hello retro coders, hello once again. This time it's another quick lesson about random number generators, or pseudo-random number generators. Of course you can't get a real random number from a computer. I've lost my trail of thought already. It's typical from me. Yeah, what I was going to say was, in a nutshell, this is another quick lesson about random number generators. However, we are going to be coding in our game code, so you'll need to get that back loaded up if you haven't already done so. The next lesson we will be getting into making our game with our power-ups and collision and everything, but this time around I really want this lesson just to be quick, to the point, purely about our random number function. And we're going to be using the bitwise operations that we just learned about. Alright, let's get going then. Where we want to put this? I'm thinking about making a file for tools, just general tools, you know, that we use in every program. But for now I'm going to keep it down here. Call it get random. Get random, bro. So that. Right, so get random. We have a new function. Returns with random number between 0 to 55, and it's going to be an A. Alright, so we've got a function now. Let's get into the habit of putting returns there, although sometimes you don't need a return if you jump back to somewhere. In fact, I'm going to say don't get into that habit, because if you are forgetful and you do that and then you call get random from another piece of code in another file or whatever, you won't get an error, but you won't get the result you want. So it's better to leave it like that. I suppose you wouldn't get an error anyway, but you'll probably easier figure out what's going on. We're going to want a seed which we store. We'll cache the value, and that's actually going to be a 16-bit number, otherwise known as a word. Let's just call it seed. Why go against the convention there? DW is just like DB, except for we're defining a 2-byte or 16-bit, as I just said multiple times. And that's really all we need. So in order to make this random number, we're going to step through memory and just read back the number from that memory address, and that is going to be fed into A. The first 8K of the Spectrum ROM, I'm reliably informed by a Jonathan Caldwell, who wrote this book, and he made several games, Game Engine. You know, I don't know everything about the guy, but he seems to have done a lot for the retro gaming community. Sounds like a pretty good dude. So I've learned all this from him. Anyway, so it steps through the memory, and as long as you keep it in the first 8K of the ROM, you can be pretty well relied. You can rely on it being pretty random. Although I have noticed some patterns. I don't know the patterns, but I'm just by where I've been spawning enemies, I've noticed sometimes they seem to spawn in the same place a little more often than others, perhaps. So obviously it's not perfect. But it's a start. We only need, we don't need it to be perfect. We're still trying. I mean, I'm still personally trying to learn how to structure an assembly program correctly. If I was trying to make a full game, such like an RPG, like Gauntlet or something, with however many levels that has and different spawners and RPG elements, the lot, I would struggle. I'm sure the Spectrum wouldn't run my code if I attempted to write that game. Be interesting to see how they did their random number generation. Anyway, always sidetracked. But so anyway, we've got a seed. We want to step through the memory. So we'll load HL, which is a 16-bit register, with the value inside seed, which is 0 right now. So that's going to look inside the first 2 bytes of our memory, of the Spectrum ROM, I should say. And if you remember, we're doing entry point 32, so this is looking nowhere near our program, Sorry, I'm having to look around my microphone. This is why I'm always slow. I can't see the whole screen. Right, so this would be all well and good, but the problem would be when the seed, we're going to increase the seed after we return a number, right? But if we go too high in the memory, we're going to get to stored data which never changes. So we're going to know in advance the number if we're clever enough, and people will be able to exploit that in our game. And it also, probably wouldn't lead to. It wouldn't seem very random to the player, even to a novice. So we need to use a bitwise operation to cap that value. And so what we need to do is we'll load A with the higher bit, the higher byte of the HL register. I don't know whether to comment that or not. Oh. All we need to do is that mask out that number in the higher byte, keep saying bit. That is the same as writing and 31. But in my opinion, it's much clearer. We're doing a bitwise operation. Why would we want to write a decimal? And then every time we look at it, we have to think, okay, what binary is 31? So what bits are we masking out? It's much better just to write it like that, in my opinion. But that's how it's written in the book. I mean, in the book, they also don't make a function. They just do it. Oh, no, in fact, no, tell a lie. They do. Thought they did it in line. Anyway, so what we've done here is we've loaded the value 0 into HL. So that's now our pointer. Oh dear. That's our pointer where we want to look to get this random number. Let's pretend it's been increased to value higher than 8,000. Then we need to make sure it goes no higher than 8,000, which is what it's doing here. We don't worry about the lower bits because you know they don't go to 8,000. So. We then load A back into H because the result of that ends up in A. A becomes the result of that. So now H is the result of that. So if H is 0, which it is, it's still going to be 0. Anyway, I hope that makes sense. I'm not the best at explaining that, but it's pretty straightforward once you've used it a few times. And that's simply it. Like I say, now we're getting the data inside that pointer into A. A is only an 8-bit register, yeah? So this number is within 0 and 255, which happens to be the same amount of pixels across the screen for obvious reasons, for the same reasons, you know, to keep the memory size down. So now we put that into A, we can increment HL. Remember, that's holding our seed capped at 8,000. And then we want to make sure the seed itself also is incremented. And we'll need a return statement. Okay, so I'm just thinking in my head now, what happens when it goes over 8,000? How does it go back to 0? It will naturally go to 0. That's what numbers do on binary. When it hits the oh, will it though? 'Cause we keep capping it. Sorry about this, I'm just making sure I haven't missed anything. All appears in order. Let's try it out. Alright, so our Y position is 10 and our X position is 0 from the start of the game. Oops, I keep doing that. Saving it, that's what I'm doing. The real eagle eyes among you would have noticed that this file path has changed. That's because when I set up my GitHub repo, it messed around, and that was the easiest way to fix it. So might as well mention while I mention that there is the GitHub. I've started to add links to my descriptions on YouTube for that GitHub. Some of them might be missing. I've done as many as I can. So you'll find the link eventually if you look around. After every lesson, although I didn't do it. Oh, we didn't change any code last time. But yeah, after every lesson I go to GitHub and push this new version, so you don't have to type any of this if you don't want to. Or obviously if you've tried to type it and I've just messed around your view and you've got it wrong, you can actually download it now. Anyway, so we're compiling textmover.asm. And then invoke item textmover.tap. It does our little melody. We started, as you can see, on 0 in the X, right? So to keep this lesson short, because it is all just about that random number function, let's make sure it works and then conclude the lesson. We're going to make him start from a random X position. And that can be done right at the start. I'll do it just before we make the sounds. So call random, get random, sorry. Put random number in A. Load xpos of A. Make xpos random. Right. It should be that straightforward to use our get random function now. Oh, he's out of range. That's not helpful to you, me zooming in. Of course, that's characters, isn't it? And I'm doing it in pixels again. Well, in that case, we'll use another and. Let's try. This is where I start getting confused with ands, but let's try that. So it's 2 zeros and 6 ones. So it should be the maximum that should be able to go to. No, that's too high. Just put there. So the maximum number that can go to is 31, I think now. Let me just test that on my calculator. Oh. Yeah. So we're just masking out any number above that. Let's try it. And there you go. Right, he's definitely started somewhere random. Is it the same every time or is it different? It might be the same every time because it gets called right at the same point every time of the program, but we'll see. Yeah, it is. So you have to come up with a way of not calling it right at the start, really. But that's something for another lesson. This lesson was all about getting a random number, and we've learned how to mask it twice. Mask. Well, let's just keep it simple. Cap to max of 31. So you have to be a bit careful with these. You can't well, I say you can't. Just wonder if that would work. I don't I don't think so, but we'll see. Seems to spawn in the same place. No, that's obviously, you need them because otherwise I'm making sure they're zero. It's always going to be that, whatever number that was, with just the one there. That number would have been 16 every time. So this, what we've done, will definitely give us a random number between 0 and 31. However, because of the point in the program where we're calling it, it's being the same every time. So I'm going to have to figure out why that is. I did manage to figure this out in my other game, but I can't remember off the top of my head. This should just move about like a nutter now, yeah. Don't know why he's not being deleted as well. Oh, because I'm moving him in the wrong place. Okay, yeah. Yeah. Well, you see what I'm getting at. I'll be deleting that, but this was just for an example of how to use the function. But next lesson we are going to be figuring out how to make him, like, well, not him spawn randomly, how to make the power-up spawn randomly. So it's going to be a lot longer session. Hopefully not too long next time, but a bit longer than this one. Alright, so look after yourselves. Be back soon. Thank you. Goodbye.